Directive Number 1. Training Modules for Interstellar Exploration. Module 4. Advanced Technology Operation and Maintenance. Module 4 focuses on equipping trainees with the knowledge and skills to operate, maintain, and troubleshoot the advanced technologies required for interstellar exploration. This module ensures that crew members are proficient in using critical systems and can respond effectively to technical challenges in remote and hostile environments. Objectives of Module 4. 1. Mastery of advanced equipment. Train in the operation of state-of-the-art systems, including propulsion, life support, and communication technologies. Understand the underlying principles of the technologies to enable quick adaptation during missions. 2. Maintenance and troubleshooting. Develop skills to identify, analyze, and resolve technical issues during a mission. Learn to perform repairs under extreme conditions with limited resources. 3. Innovation and improvisation. Foster creative problem solving for unforeseen challenges. Train in constructing temporary solutions using available materials. 4. Safety and risk mitigation. Ensure all systems are maintained for crew safety and mission success. Train in identifying potential risks and implementing preventative measures. Module structure. This module is divided into 4 sections, each addressing a specific area of technology and its application in interstellar exploration. Section 1. Propulsion Systems and Navigation. This section provides in-depth training on the operation and maintenance of propulsion and navigation systems critical for interstellar travel. Key topics. Propulsion systems. Master the mechanics of advanced propulsion systems, including fusion drives, antimatter engines, and gravitational wave drives. Learn fuel efficiency optimization and emergency shutdown procedures. Navigation protocols. Train in plotting interstellar routes using stellar maps, gravitational fields, and quantum coordinates. Understand the use of AI navigation aids and manual overrides for precise maneuvering. System diagnostics. Use diagnostic tools to monitor propulsion system health. Identify and address issues such as fuel leaks, component wear, and system malfunctions. Section 2. Life Support and Environmental Systems. This section focuses on the technologies that sustain human life in space and on alien planets. Key topics. Atmospheric control. Operate systems that regulate oxygen, carbon dioxide, humidity, and pressure within the spacecraft. Learn to detect and resolve atmospheric imbalances or toxic leaks. Water and waste management. Manage closed-loop systems for water purification and waste recycling. Troubleshoot issues to ensure sustainable resource use. Temperature regulation. Monitor and control thermal systems to maintain optimal conditions in extreme environments. Contamination prevention. Operate decontamination chambers and quarantine zones to prevent biological or chemical hazards. Section 3. Communication and data systems. This section ensures trainees can effectively use and maintain communication and data technologies, crucial for mission coordination and safety. Key topics. Interstellar communication. Use quantum entanglement systems and subspace relays for real-time communication over vast distances. Troubleshoot signal interference and repair communication arrays. Data storage and security. Maintain and secure mission data using advanced encryption methods. Learn to recover data from damaged or compromised systems. AI and automation. Operate AI systems for mission support, diagnostics, and decision-making. Train in overriding or recalibrating AI functions during malfunctions. Section 4. Tools for Innovation and Improvisation. This section develops creative problem solving and resourcefulness in responding to equipment failures or environmental challenges. Key topics. Improvisation with limited resources. Learn to repurpose tools and materials to address unexpected issues. Develop contingency plans for critical failures. Modular system training. Understand modular design principles to replace or repair components efficiently. Practice assembling and disassembling key systems in simulation. Remote repairs. Train in using drones and remote-controlled robotics for repairs in hazardous or inaccessible areas. Training methodologies. To ensure comprehensive preparation, Module 4 employs a combination of theoretical learning, practical exercises, and simulated scenarios. 1. Hands-on practice. Operate propulsion, life support, and communication systems in controlled environments. Practice repairs on mock-ups and real equipment under various conditions. 2. Simulated emergencies. Participate in simulated system failures, such as propulsion malfunctions or life support breakdowns, to practice troubleshooting under pressure. 3. Virtual reality environments. Train in VR scenarios replicating technical challenges on alien planets or in deep space. 4. Field training. Work in analog environments, such as remote deserts or underwater habitats, to simulate space-like conditions. 5. Innovation workshops. Collaborate with team members to solve hypothetical problems using limited tools and resources. Evaluation and certification. Trainees are evaluated through both theoretical exams and practical tests. To earn certification as an interstellar systems specialist, trainees must demonstrate proficiency in operating and maintaining propulsion, life support, and communication systems. Successfully resolve simulated system failures and emergencies. Exhibit creativity and resourcefulness in solving unforeseen technical challenges. Conclusion. Module 4. Advanced technology operation and maintenance ensures that every crew member is fully prepared to manage the sophisticated systems essential for interstellar missions. By mastering these technologies, explorers are equipped to safeguard their missions and represent humanity as a capable and responsible civilization in the cosmos. Dr. Ong Der EDF